Anyway, as you can see, it's this player's turn, so we can actually use our arrow keys to move the player, and as you can see, the player moved to this spot. Hey guys, and welcome back to Dev, and today we are gonna be doing the long-awaited video. Exactly, today we're gonna be building a multiplayer system using Firebase, or at least we're gonna do an example of it. Now this video is gonna be a little bit different than the other ones because we're not gonna actually build it live, but I'm just gonna show you the final result and then we're gonna go check out all of the code that I wrote. And the reason I'm doing this is because every single thing that you're gonna see in this code pretty soon is something that I already talked about in other tutorials. I already did a lot of tutorials about Firebase, really basic ones, that could explain, you know, the basic of real-time database, the basic of cloud functions, the basic of authentications, and today we're gonna put all of that stuff together to create this simple multiplayer game. Now this means that if you get stuck on any section of this video, I'm gonna recommend to you the, intended playlist that you can watch, and with that playlist you can get an in-depth course on what we are trying to achieve, or that specific thing that we're trying to do. I wanna keep this video short, so we should jump right into it. I'm gonna show you the final result at first. And also, the code is already all in the description, so if you are one of those guys that, only wants the code, you can find it in the description. Before leaving though, leave a like on the video because that would really support the channel and show some appreciation. I have two different instances of the app, the one on the left and the one on the right. We're gonna call this one left, okay? And as you can see, it's gonna be looking for an opponent. Right now it's in the matchmaking. And we're gonna call this one right, okay? And right now it's also looking for an opponent. Now they're gonna find each other, so as you can see it's gonna say found, waiting for players to be ready. And now the left player is gonna be ready. And also I'm gonna set the right player as ready, and now as you can see they will join a match. So these two players are both synced and are both in the same match. Now this is a turn-based game, so this means that only one player can move at a time. But I made it this way just as an example. Naturally you can do any kind of games using the Firebase system. Now you could also do FPS games, so first-person shooters, but naturally Firebase is a in-depth database, and it would be pretty slow to do a first-person shooter, but you could do it anyway. I think the best thing to do in Firebase is doing turn-based games. So I don't know, if you want to replicate chess, for example, it's a really good use. Anyway, as you can see, it's this player's turn, so we can actually use our arrow keys to move the player, and as you can see, the player moved to this spot. Now, if a player is red, it means that it's the local player, while if a player is blue, it means that it's the remote player, so the other player. So as you can see on this screen, I moved to the right, and if I go to the other instance, as you can see, I also moved to the right, because I'm the blue player. Now, the red player, which is me, is gonna move to the left, and as you can see, I will move to the left, and if I go to the other instance, I will also be moved to the left. And now I can keep doing moves, and as you can see, it's gonna update pretty much immediately on both instances. And so this works. This is basically the multiplayer system I created. The code is all in the description, and now we're gonna analyze it in depth so you guys know exactly how it works. Okay, also you can leave and join again. This is the only thing I didn't showcase, okay. Alright, let's close both of these apps because we don't care about them anymore, and let's actually dive into the code. Now, I want to start simple, okay? Before actually looking at the code, let's actually see how the scenes are structured and also how the code is structured, okay? Because if you understand and if you grasp the structure of the code and, the way all of the different components and classes are called, it's actually pretty simple and straightforward to understand the meaning of what they do and, what's their function in the entire app. So let's start with the scenes. We have 4 different scenes. The first scene is just the loading scene. I usually add these scenes to the project. This is basically the scene where the project loads on. Now, as you can see, we don't have anything fancy, we just have a camera, okay? And we have 2 game objects. We have a manager and a handler. Now, the way I structure apps in my head is that every single scene has its own handler, okay? And basically what the handler does is that it takes care of all of the UI that's in the scene. So as you can see right now we are in the loading scene. If we go to the menu scene will also have its own handler. And this handler will take care of the menu scene, all of the UI in the menu scene. All the other scenes also have their handlers for the specific scene they are on, but the first one also has a manager. Basically, the managers are classes that can be called everywhere in the entire app. So this is how I structured the scripts. I divided my scripts into handlers and managers. Handlers are specific for that scene, while managers are global. They are done for every single scene. And as you can see right here, we have a few managers, and we're gonna go more in depth about all of these. And basically, this is actually what makes our multiplayer system work. So this loading scene, all that it does is that it loads our managers and then it brings the user into the menu scene. This is the menu scene, you probably remember it from when you loaded the app. Now in the menu scene we have an input field which is gonna decide the player ID, and we have a button that starts the queue, so it starts putting the player into the matchmaking. Okay, so this multiplayer system was done using Firebase Realtime Database, and so that you can grasp how this works, oh wait, that's my OBS, but so that you can grasp how this works, we're gonna basically load the app just for a second, and as you can see we're gonna go into the menu scene right away, and I'm gonna show you what is happening to the database when a user enters the queue. So as you can see, I'm gonna call myself Nico, and I'm gonna enter the queue. And as you can see in the database, we're gonna have a new branch, which is matchmaking, and there's gonna be Nico, and nearby Nico there is gonna be a placeholder. Now, I don't wanna create another instance of this app, so let me just manipulate a little bit the data, and let's pretend that I created a new user, which is gonna be Happy, at example. It's just the name of another user. We're gonna have placeholder right here, and we're gonna do add, and now pay attention to what happens once I do this. So basically the system, the Firebase, matched the two users together and it created a game. It created a game with a certain ID. And now both of the players, both me, Nico, and Happy, have the ID because it got stored right here. So what they can do is that they both can connect to the game that was just created. And if we go into the game, as you can see, there is going to be some info on the game. At example, the ID of the game, and also how many players are connected to the game. As you can see, we have Happy and Nico. These are the two players. Also, it's gonna tell us whose turn it is, and in this case, the turn goes to Happy. But now, before starting the game, we need the players to actually be ready. So if I click on this button right here, we can click on ready, and as you can see inside the game, there is gonna be a new branch which is gonna be called ready, and right here is gonna say that Nico is actually ready. Now again, Happy is not a real user because we actually didn't open any apps. I just created it myself, but I'm gonna pretend to be Happy again, and I'm gonna, set myself as ready. Once both me and Happy are ready, the game is gonna start. And now, as you can see, it's Happy's turn. So I cannot actually make any move. But if I go here and I change the turn, and instead of it being Happy's turn, I make it be my turn, as you can see in my game, it's gonna say that it's my turn, and I will be able to move my character, and as you can see, it will move. Now the turn will go back to Happy, because I already, did the move, so it's Happy's turn again, but I can force it again to be my turn, and I can do another move, and as you can see, it will work. The red player is me, the blue player is Happy, and if I do it one more time, Nico, and I go down, as you can see, it's gonna keep working. So basically, this is how the database is structured, how the information is going through. And now I'm gonna actually show you the code that makes this work. Now let's actually leave the game. And one thing I didn't implement is actually a system that deletes the game once the game is over. So we need to delete it automatically, they just delete the entire database, so it's completely cleared. Okay, next up we have the matchmaking scene, and basically all that this scene does is that it puts the player into the matchmaking queue, okay, and it waits for the player to receive a match ID. Once the player has received a match ID, then it will prompt him to be ready or not. And if all of the players are ready, then it's gonna bring the player into the game scene. And the game scene is also pretty straightforward. If it's the player's turn, then the player is gonna make a move, and that move is gonna be uploaded onto the database, and then the other player will be able to retrieve that move and execute it. So now I've shown you, structurally, how the game works. Let's actually look into the code and see how, all of this stuff is orchestrated together. Now the first thing you want to do if you want to make this work is that you gotta import Firebase SDK into your Unity project. Now I already did that, and if you download my version from GitHub, you're gonna have it sorted. If this is the first time you're doing anything with Unity and Firebase though, I suggest you watching another playlist I did, which is called Making a Chat System in Firebase. In that playlist I actually went more in depth on how to incorporate the Firebase SDK in your project, so you can watch that first if you are confused. Or at least watch the first episode, that is all you need. Anyway, we're gonna dive straight into the code, and as you can see right here we have our scripts. As I explained before, we have our handlers, which are basically the scripts that handle the UI for each scene, and we have our managers, which is basically all of the global scripts, all of the utilities that we're always gonna use. Plus, we have our serializable, which are basically objects that we can push and retrieve from the database. An example, I can push a move, and all that the move is a vector 2, which will indicate in which direction the player will move, an example. Or also we have another object, which is basically the game info, which is gonna be the game ID, and how many players the game has, and all of that stuff. Finally, we have our APIs, and our APIs are the really lowest level of the chain. They are basically simple utilities, such as posting any JSON to the database, or retrieving any JSON from the database. Now, I created this utility class a long time ago. I think I also went in depth through it in the Firebase chat tutorial system. So as always, if you want more information on how this code works, even if it's pretty straightforward, you can go check out that video. But basically all that this does is that it uses the Firebase SDK and pushes and retrieves stuff from the database. Alright, let's begin with our first scene, the loading scene. As soon as the player starts the app, the database is going to be initialized. The Firebase database is going to be initialized with the database URL, which is going to be the one you're going to set. Right now, my project ID is Nico the Bot. It's just a random project that I created. This is going to be your project ID for your Firebase project. And also, I'm going to set the reference to the database, which is just going to be the root of the database. Just for safekeeping, so I can use it in all of the other functions. After I have correctly initialized the database, I can load the menu scene. I have nothing else to do. Also, in this scene, we're gonna initialize, if I go to the scene, basically this main manager just as a reference to every other manager, which is the matchmaking manager and the game manager. And we're gonna go in depth about these managers really soon. But this main manager has a reference to both of them, and also is a singleton, which means that can be called from anywhere. So every time we want to call a manager, all we have to do is use this instance right here, and then call either of the managers we want, because we're always gonna have a correct reference to these objects, these classes. And basically this is all you need initialization wise. Now we can hop onto the menu scene. This menu scene, as I explained before already, all we need to do is enter the user into the queue. So we need to get the ID of the user and then make him join the waiting queue. So if we go to the menu scene handler, we're gonna have all of the UI about the scene. And naturally there is not that much UI. All of the UI that is there is the input field, which is this one, and the play button. Basically all that this scene does is that it stores the result of the input field into a local variable. It actually stores it into this variable right here, and then it moves the user onto the next scene, the matchmaking scene. Now, why am I storing the player ID into this variable? This doesn't seem really clean. Right now, the user can decide what is his user ID. To keep this video simple, I didn't introduce any authentication to the users or anything like that. The user just types in his name, and his name is used as an identificator for the user. This means that two users cannot have the same name, or stuff is gonna glitch out. To solve this, it's really simple. All you have to do is implement Firebase authentication in your Unity project. And I also made a video explaining Firebase authentication. It's in the Firebase chat tutorial playlist. I think everything you need is right there, honestly. And yeah, once you actually implement authentication in your Firebase project, instead of storing the player ID from the input field, you have to store the player user ID that you get from Firebase authentication. So I created this example in a simple way such that it can be expanded with other Firebase services such as authentication. And I even made a comment about it right here. Alright, but now that we are all set up, we can actually go into our third scene, and it's the matchmaking scene which actually starts doing requests and sending stuff to the database. Because as soon as we enter this scene, if we go into the matchmaking scene handler, let me navigate to it, yes, right here, in the start function we're actually gonna join the queue. And all of that this does is that it calls the matchmaking manager, which is one of the two managers that I created for this project, and it's gonna run the function join queue. This function basically posts the player ID into the matchmaking branch, and it sets a value of a placeholder. This is just a way to tell the database, hey, now I'm in the queue, start matching me up. And as you can see, this is just an example. If I hit play, this is gonna do exactly what I said. So this code right here is basically gonna send a request to the database, and it's gonna post this data. It's gonna post inside of the matchmaking, it's gonna post my name and a placeholder. Once the user gets matched, this placeholder will be changed to the match ID. We have a similar thing for leaving the queue. Basically, it will post to the same location, but it will post null, so it will actually remove the data. So if I actually click on leave, as you can see, I'm gonna leave the queue. Now, probably the thing you're most interested and you're all here for is actually the matchmaking system. Because you're like, okay, the database magically recognizes two users and magically puts them together. How do you do that? As you can see, I'm gonna show you one more time what I mean by that. If I create a new user, which is Nico, okay, it's gonna be right here, and then I create a new one, which is Happy, and I call it placeholder. As soon as I add this user is gonna get matched with Nico. And as you can see, I do this, and this user is getting matched. And the game is getting created. So what code makes this happen? Where is the code that does all of these shenanigans? The code that makes this happen, that makes the matchmaking system work, is not on the client side, obviously, so it's not to be found inside Unity or, inside our project, but it's actually done inside Firebase itself. It's done using Cloud Functions. Basically, if you don't know what Cloud Functions are, you are in luck, because I made an entire playlist showing how to do basic Cloud Functions. So if you are new to Cloud Functions, you can check out that playlist. But basically what they are some code written in JavaScript that can get executed when you perform a certain action. In our case, the code is gonna get executed every time a new user joins the queue. And now let's go check out that code. Now, even if the code doesn't need to be in the Unity project, because it has nothing to do with the Unity project, I actually stored it into the Unity project for safekeeping, and it's just outside the assets folder, it's in the Firebase folder. So if you go right here and you go in functions and you go in index.javascript, you are gonna see the Cloud Function code. As always, if you are new to Cloud Functions, you can check out my tutorial on it. It's pretty straightforward once you get the grasp of it, and you will be able to incorporate this code into your project, so you can use this example and expand it. In our Cloud Functions, we only have one function, which is this one, okay? And it's called the matchmaker. This function gets executed every time there is a new node into the matchmaking folder. Basically, all that this function does is that it generates a new game ID, okay? And the way I generate the game or match ID is pretty simple. I just use randomness, okay? And I generate a random string. Naturally, you can make this whatever you want. For me, just randomness is enough for this example. And it stores this game ID. Then it will get all of the players that are currently in the queue, so it will get all of the matchmaking players. And from all of these players, which are these ones, okay, that it just retrieved, it will iterate over each player, and it will check for all of the players that still have a placeholder as their value. Meaning it will try to find if there is a player that is still not into any match. It still hasn't matched with anyone else. And it will also make sure that this player is not the same player that just entered the queue, okay? Because we don't want to match the player with himself. So basically this is what the code is doing. It's basically checking if the player is not in any other match, and also it's gonna check if the player is not the same player that just joined. And if it finds a player that meets this requirement, it's gonna store them into second player. Finally, we're gonna check if second player is null, and if second player is null, it means that there is currently only one player in the queue, so we cannot do anything. But if second player is not null, then we can create our game. We will create a new object, which is our game, and inside our object we're gonna have game info, which is basically gonna have info on the game, it's gonna have the game ID, it's gonna have all of the different players, so the first player, which is basically this one, and the second player, which is the one we stored right here. And then it's gonna also decide whose turn it is to begin with. And then all of this information that we just created is gonna push it into a game that it will create, with the ID of the game that it just generated. Okay, and once it generated the game, okay, so this code is gonna execute once the game was generated and was pushed into the database. It's gonna update the information of both the first player, which is this one, and the second player, which is this one, and instead of the placeholder, it's gonna set them the game ID. Now, all of this happens like in a second or in a millisecond, so it's really hard to see, but now that you know what is happening in the background, if I delete all of this information and try again, you will, have a better clue of what is happening. Okay, so let's test it out and let's see, if you guys can grasp it better now that I explained how it works. But basically, if we create a matchmaking folder and inside of it we put Nico with a value of placeholder, and then we put happy with a value of placeholder, as soon as I hit enter, this function will execute and will do all of the code right here. It will match happy, which is the new player, with the second player, which is gonna be Nico. It's gonna generate a new match, it's gonna push the match onto the database, and then it's gonna give both me and happy the new match ID. And I hit enter, and all of that just happened. The new match got created with all of the info, and also we have both of our match IDs. So basically this is all of the code that happens on the server side. Now we can go back to the client side. Let me delete everything and let me join again. Right now I'm looking for an opponent. So if I actually go to the matchmaking scene handler again, if we go back to the join queue function, in this function there is also a callback. And a callback is basically some code that gets executed once an action is completed. And right here, this code right here, in this callback, will get executed once a game is found. Basically, I know this code seems really messy because it's really condensed, but basically what this does, actually let me expand this so it's more readable. Let me do this, and okay, now it's more readable. But basically, after the user is put into the queue, so as you can see we push the information of the user into the queue, we're also gonna listen for when that placeholder information has changed. So right here we're gonna add a listener and we're basically gonna wait for when that value changes. And this is a really low level because it's in the database API function, and it's basically gonna listen for any update that happens into the placeholder thing right here. And as you can see, this thing has a callback, okay, right here. And this callback is gonna get called when there is any updates on the node. So every time this placeholder data gets changed, this code is gonna get called. In our case, this value is only gonna get changed once the match is found, and this value is gonna get changed to the match ID. So this means that if we set up this listener properly, just like we did right here, the code in the callback, which is this code right here, is only gonna be called once we find our game, or once the server matches us with another user. So once this happens, I actually will leave the queue, because I found my game, I don't need to be in the queue anymore, so I will leave the queue, and then I will call the function onGameFound. I will call this callback. And what this callback actually does, right here, is just, gonna set a flag and it's gonna say the game was found. And when the game is found, right here, we are gonna call this function, which is the GameFound function. So this is a really convoluted, piece of code, a lot of back and forward, but basically all this does is it sets up a listener for this place on the database, and every time this value changes, it will execute a piece of code. And the piece of code that it will execute is this one. And also the user will leave the queue. So I can show you just an example right here. I think the app is already running. If I change this piece of code, this piece of data right here, and I hit enter, as you can see, the player will actually leave the queue because he realized that, the game is ready. Okay, another thing that it does once the game is actually found is it's gonna try to get all of the info about the game. So it's gonna try to retrieve the current game info. In our case, since the game ID that I just gave him was fake, the user actually didn't manage to retrieve anything. And as you can see, if I try to ready up, it's gonna give me errors because there is no game. I actually invented that game ID, and so naturally, Unity is having trouble actually sending me or making me ready on that node. But yeah, what basically I do is that I retrieve the current game ID info, and if you remember, this info that I'm trying to get is the info that I set in the backend using the cloud function. This info right here. And I need this info to know if it's my turn or not, and also how many other players are in the game. Naturally, right now in this example I'm only doing 2-player games, but you can expand this code really easily to match up multiple people, and you could have infinite player games just with the same lines of code. Alright, once we retrieve our game info, I think I will store this somewhere. Yeah, I think I do store it somewhere. I store it in the game manager itself. So I store it right here for safekeeping. But also another thing I do is that I need to communicate to the server that I'm ready, okay? And also I need to listen for when all of the other players are also ready. So this is what I do. I listen for all of the other players being ready. And this code right here gets executed once all of the players are ready. In fact, once all of the players are ready, I'm gonna send the user into the game scene so he can actually play the game. While this other code right here, I know it's convoluted, but this other code right here gets executed once one player is ready, so I know exactly whoever players are ready. So it's gonna say, this player just got ready. And if we go to the listen for all players ready function that I created, this is basically how it works. Naturally, it will need as a parameter a list of all of the players that are, in the game. In our case, it's just 2. And it will match the players into a dictionary, so it will remember whoever players are ready. This is a dictionary string bool, so it will match the player IDs with a boolean. So if the boolean is false, it means that the player is still not ready. When the boolean is true, it means that the player is ready. And then again, we're gonna have a listener for when a new player, set its status to be ready. And if I create a real game, maybe I can show you what I mean by that. Let me stop myself up as Nico. Let me create a fake happy user. We are gonna create a game automatically. And now we can set ourselves as ready. As you can see, inside the game we have all of this stuff. Once I click on ready, I will set my status to be ready. And as you can see, this new branch will appear and a new child will be created, which will be Nico, and its value is gonna be set to true. Now this listener right here will actually listen for when a new child gets added exactly in this path. So every time a new child gets added here, this function is gonna be executed. And basically what this function will do is it will make the player that just, set himself as ready, it will set him to true in the dictionary, okay? And then it will go through the entire dictionary and it will check if all of the players are ready. And if all of the players are ready, it's gonna call the all players ready callback. If that's not the case, it's just gonna end its run here. And now in my case, when I set myself as ready, this code actually got run. And as you can see, this callback actually went through. And you know that it went through because if I go right here, in this callback we have debug.log, player ID is ready. And as you can see, if I go into Unity and I go in the console, it's gonna say Nico is ready. But the other code, this one, didn't get run because not all of the players are ready. In fact, happy is still not ready. But if I go here and I go happy and I set this to true and I do add, now if I go back to Unity, it's gonna say also happy is ready because it was listening for this event and it was listening for, this other player to be ready. And then when it goes through this code again, it will realize that all of the players are ready, so it will stop listening for all of the players, and also it will execute this callback. And basically what this callback does is that it says all players are ready, and also it loads the game scene. And this is exactly what happened in the game. It says all players are ready, and now I'm on the final scene, the game scene. So just to reiterate, what did we just do? We took 2 random players, okay, we mashed them together into the same match, into the same database location, and now they have this safe space that they can share together, where they can share their game information, and they will be able to play. So they both know the match ID, and the match ID is the same for both of the players, so any data that they write inside this branch, also the other player can be aware of it and can see it. And on this note, we are completely done with matchmaking. Now all we need to worry about is the actual game, so actually submitting the moves and retrieving the moves. That is all that is left. And this all gets handled into the game scene, of course. In the game scene, we have an handler, which is a game scene handler. Now, in the game scene, there is not that much UI. The only UI that is there is the leave button. And basically, all that the leave button does is that it sends us back into the menu scene. So not really a lot to talk about. But if we actually go into the game scene handler, we can see that we also have some code that executes right on start. So whenever we join the game scene, we need to spawn our 2 users, okay? The blue user, which is the remote one, and the red user, which is us, okay? The local one. I created a prefab for these users, and so I just spawned them in the start function using instantiate. Now, do you remember when a long time ago I told you I stored the information about the game for safekeeping into the game manager? When we did the get current game info function? Now this game info is gonna come useful, because we're gonna use this game info to get the current number of players, and then we're gonna iterate for each player. And for each player that is there, and in our case it's always 2, we are gonna create a new object, so a new square, okay, to, you know, keep track of that player. Each of these players also has a class attached to them. This class is called the player handler, and we're gonna go through this class in just a sec. Now, for safekeeping, we are storing in the player handler class the ID of the player, also whether the player is the local player or not. And the way I know this is that I just, see if the player ID of this player is the same as the one that we inputted a long time ago into the origin input field. And so if it's the same, it means that the player I'm currently, retrieving information from, or the player I'm currently instantiating, is me, okay? Is actually my character. And then I pass him this text, but, this is just a UI stuff, it's not really important. Okay, and this is all there is to say for the game scene handler. Now, all of the rest of the code is getting executed inside the player handler function. Or sorry, the player handler class. Basically, each player has an instance of this class. So as you can see, I generated 2 players right here. The red player, which is me, and the blue player, which is Happy. And both of these players have a player handler instance. Now, what does the player handler do? As soon as the player handler starts, so the player gets instantiated, it will check if the player is a local player or not. If the player is a local player, then we're gonna, color him red, of course, and if it's not, we're gonna color him blue. But also, if the player is a local player, then we're gonna start to listen for when it's our turn. Basically, what we're gonna do is we're gonna add a Firebase listener to this place right here in the database. This branch, right here. So games, game ID, turn. And we're gonna check for whenever this turn matches my name. So if this turn function, this turn value is equal to Nico, then I know that it's my turn. And this code is gonna get executed. And if we go inside this function, this is exactly what it does. It will listen for a change in value on the correct path. And then if that change occurred, then it will check if the turn, the value, is the same as my player ID, and if it is, then it's gonna execute the callback. And the callback is basically gonna say that it's my turn, and it's gonna set a flag saying that it's my turn to true. Okay, perfecto. And now, once this flag is true, if we go right here in the update, disregard all of this code for now, we don't need it. But basically, if it's my turn, so the local player turn is true, then we're gonna be able to execute this code right here. This code gets executed in update, so it means that it runs every single tick, and it will basically check for my input. It will check if I pressed the right key or the left key or the up or down key on my keyboard using the Unity input system. And if I pressed any of those keys, it will generate a new move, okay, with a new direction, and the direction is gonna be depending on where I moved. If I moved up, the x-axis is gonna be 0, while the y-axis is gonna be 1, as example. If I moved down, it's gonna be 0, -1. So I will generate a new move, and then I'm gonna use the game manager to send the move onto the database. And this code is pretty straightforward. All it does is that it pushes an object, which is our move, into the game, current game ID, player ID, moves, and then it's gonna push the move right there. You're gonna see it in action once we actually play the game. It's not my turn right now, so let me actually switch it over to my turn, and let's actually move. And as you can see, it actually generated the move into Nico, moves, and this is my move. The move has a direction, and as you can see, I moved to the right, so the direction was x equals 1 and y equals 0. Once we actually send the move, and this actually succeeds, we are gonna change the turn, because naturally it cannot be always my turn, so I need to send, I'm gonna make the other player have his turn, so we're gonna set the turn to the other player, and this function does exactly that. It posts an object, which is basically the other player ID, happy, right here in the turn, and as you can see now turn is happy. I can do this again if you guys didn't see it last time. Now the turn is Nico. Once I actually make a move, the turn is gonna be happy. Whoever is playing happy on the other computer will also be listening to when it's their turn, and once it's their turn, everything is gonna repeat. This function is gonna execute again, this flag is gonna be set to true, and they're gonna be able to make a move again. So this is basically how we alternate between each user. And I implemented it in a way that you can also make this happen with multiple users, not just two. So you can basically iterate between any user that you want. Now, before continuing, I just want to make a note about security. This is just an example, okay? There are no security rules on this example. This means that if the user wanted, they could, modify the source code or even manipulate it in order to actually make it always their turn, or maybe cheat the game and submit an illegal move. Now, the only way to fix these problems is to have a server that always validates what you do and always says, okay, this is an illegal move, you cannot submit it, or this is not your turn, you have to wait for your turn. Since this is a really simple example, I thought I could keep all of this stuff on the client side, but naturally, if you actually want to make a famous game that a lot of people are gonna play, you also need to worry about security, so this is just an heads up for you, in case you want to implement this in the future. But yeah, for now, we don't need to care about this. And now, lastly, the only thing that is left to showcase, we showed how to submit moves, we showed how to change turns, now we actually have to show how to retrieve moves, and you probably guessed it already, there is a listener right here. Let's pretend I'm happy, okay? If I'm happy, I have a listener into the Nico user in moves, and I will listen for when a new child gets added into this branch. And whenever a new child gets added, basically there is a new move, I will retrieve this move and I will execute it. And the code that does that is right here. Let me go to the player handler. Okay, right here. We checked out the code that happens if the user is local, but what if the user is not local? Well, then we have to listen for his moves. So we're gonna create a new listener that will listen for basically this spot on the database right here, and it will listen for new children getting added. And once a new children gets added, we are gonna retrieve it from right here. We're gonna retrieve the children. It's gonna be this one. And we are gonna, this is basically the callback. We're gonna execute as a callback this function, which is execute move. And basically all that it does is it sets the move to execute to move, and it will set the flag execute move to true. And if we go back to update, as you can see right here, this is the code that does that. If the execute move flag is true, then we're gonna actually move our square to the desired position, to the desired direction. Now basically this is all of the code and all of the structure and all you need to know. There is one extra that I wanted to say, because maybe some of you guys that know how this works might be a little bit confused. They may be like, Nico, why are you doing all of this weird flag and switcheroo? Can't you just copy this code and put it right here? Wouldn't this accomplish the same effect? So once the move is getting executed, I'm actually just updating the position of the user? Well, in an ideal world, this would actually work, but there is a problem. Unfortunately, Unity physics updates can only happen on the main thread. This means that if you try to update anything Unity related, such as a transform or anything else, and you are not on the main thread, you are either gonna get an exception or a crash, or nothing is gonna happen. So for this reason, I cannot execute this code right here, but I have to do this flag system and actually execute the code on the next tick, right here, in the update function, because I know that the update function will always run on the main thread. The reason this code is not running on the main thread is because this code directly comes from a callback, which is this callback right here. And the callback is not synchronous, it's actually asynchronous, so it's not running on the main thread, and putting the code here is gonna give me problems. So this is why I'm always using these flags, both here and also here, when, I'm changing turns. And yeah, this is it. This is all you needed to know code-wise. Now, I know that was a lot of information. I tried to keep it as concise as possible and show you the entire procedure. What we're gonna do right now, just to reiterate and end the video, we are gonna go into our builds and we're gonna test the app again, but now with all of the knowledge that we already have about the system. We're gonna clean up the entire database so we can do this safely. Let's open 2 instances of the app and let's try. So this is basically the same thing that we did at the beginning of the video. Alright, we're gonna have the first user which is gonna be Nico, and now he's gonna be looking for an opponent. In fact, it's gonna be right here in the matchmaking. And then we're gonna have our second user, which is gonna be Happy, and this user is also gonna be looking for an opponent, and as soon as I hit this button, the backend is gonna match these users together, it's gonna generate a game, and these 2 users are gonna recognize that they are in a game, and they are gonna wait for both players to be ready. So all of this is gonna happen when I click the play button. And wait for it, there we go, found waiting for players to be ready. As you can see, both players left the queue, the game got added, we have, okay, it's Happy's turn first, we have the game info, we have the game ID, we have both of the players which are Happy and Nico. Now we just have to wait for the players to be to be ready. I click on ready and the first player is gonna be ready, Happy is now ready. Then I go right here and the second player is also gonna be ready, which is me. And now that both players are ready, we can start the match. Right now it's Happy's turn, so if we go to Happy's screen, it's gonna say it's your turn. And if I actually move, I'm gonna move down, okay? So if I move down, it's not gonna be my turn anymore. As you can see, the right player, which is Happy, or which is the local player, has moved down. And right here, as you can see, the remote player also has turned down. If I go back to the database, as you can see, it's gonna say that it's Nico's turn now. And inside the Happy folder, in moves, we're gonna have a new move, which is gonna say that I moved downwards. And now if I go back to Happy, I will not be able to make a move, because naturally it's not my turn. But if I go right here, I can make a move, and this time I'm gonna move left. And as you can see, it did work, it did update on the other screen. And as you can see in Nico moves, we're gonna have our move, and as you can see, it worked. And now it's Happy's turn again. Now what I can do is I can use Alt-Tab to quickly switch through the instances, so I can quickly make some moves, and I can show you how fast this system actually is. So I make a move and I switch, and as you can see some delay, but honestly it's really understandable if I'm using, I'm using Firebase to do this. And Firebase is not intended for, instant multiplayer and stuff like that. But for turn-based games, it works pretty fine. As you can see, there is not that much lag. And as you can see, I can make all of the moves that I want, and it's gonna work pretty flawlessly. And once I'm done, I'm gonna leave, and I'm gonna leave again. Now, I think I said this before at the beginning of the video, but once you actually leave, the game doesn't get deleted, and this is bad. You should have like a check or a cloud function that makes you delete the game once both of the players are left. Or if you want to code in a really stupid and spaghetti way, you can also make the users on the client side delete their own games. But that is really risky because, if a user hacks your source code, then if they are losing a game, they can just delete the game and pretend that it never happened. Or also they can delete other people's games, so this is not what we want. The best way to incorporate this system in a mature way is to make everything happen on the server side. So you can have a cloud function that checks maybe if players have not done a move in 10 minutes or even in an hour. And if the game has been idle for an hour, then you can delete the function. If you want to know how to do this, you need to use scheduled functions, which are basically functions that run once every hour, once every 30 minutes, once every interval of time that you want. I made a tutorial on scheduled functions too, so you can check that out. It's gonna all be linked in the description. And yeah, this is it. I tried to make this as simple and as explanative as possible. I don't even know if that's a word. Okay, but as concise as possible. So if you really enjoyed this tutorial and you're looking forward for more Firebase and AI tutorials that I'm gonna do in the future, you can check out my channel and subscribe and leave a like and all of that stuff. And wow, this was a big video. A lot of information, a lot of stuff to say. I hope you really liked it and, suggest me ideas for more videos. All of the code that you saw is in the description, and also in the description on GitHub. I'm gonna leave a README that is also gonna have a bunch of information for integrating this into your own code base, so you can go check that out if you are confused. And yeah, this is it. I hope you really enjoyed this video. I think this is the 4th time I said this. Leave a like if you did, and I'm gonna see you guys in the next one. See ya!